Hello, fellow chemists. In this video, we're going to take a look at an introduction to drawing Lewis structures. This is labeled as an intermediate level video because it assumes you have a basic understanding of covalent bonding. If you need a review of that topic, I will put a link in the upper right-hand corner. So Lewis structures, these are, kind of have an example of one drawn here. These are structures that are drawn only for covalent compounds. And basically, you're usually given a formula, and then from that formula, you're asked to figure out how those atoms are attached to each other and draw their Lewis structures. So let's do a couple of examples here for Lewis structures. So if we take a look at the molecule H2O, water. That means you have 2 hydrogens and 1 oxygen. And if you're asked to convert that into a Lewis structure, the first thing that you want to do is draw out the dot structures for the elements involved. Remember, the dot structures are just showing you the valence electrons only. So hydrogens each have 1 valence electron, so their dot structures would look like this. And then oxygen has 6 valence electrons. Put 1 on each side first. And then you can start to double them up. So I'll double 1 up here and double 1 up here. And what you then do is you just kind of take a look at how many bonds each atom is going to want to make. This hydrogen will want to make 1 bond because it has 1 non-bond or has 1 bonding valence electron, 1 non-paired valence electron. And this hydrogen will want to make 1 bond. The oxygen will want to make a total of 2 bonds. 1 from each of the non-grouped electrons. Remember, these are non-bonding electrons here. So there's 2 bonds that the oxygen will want to make. Then you just kind of start pairing up the electrons so that each atom makes the number of bonds that it wants to make. So that could make a bond there. And these guys can make a bond here. So the oxygen is going to make 2 bonds, 1 to each hydrogen, and each hydrogen will make 1 bond to the oxygen. Then if we draw the actual Lewis structures out for each bond, you represent that as a line. And then you still draw in the non-bonding electrons for the oxygen. So this would be a Lewis structure for water. This line here represents 2 electrons being shared, a single covalent bond. And this line here represents 2 electrons being shared, a single covalent bond. And these are 4 non-bonding electrons that oxygen has on it. So let's take a look at an example of another molecule, and this one will be CH4. So if you have CH4, you have 1 carbon and 4 hydrogens. Well, if we draw the dot structures, each hydrogen will have 1 valence electron, and all 4 of those hydrogens are all going to want to make 1 bond each. Okay, for a total of 4 bonds. Then if we take a look at the carbon has 4 valence electrons. None of them are non-bonding electrons, so all 4 of these are going to want to make a bond. So this carbon will also want to make 4 bonds. And what you're going to end up having is each hydrogen will bond with the carbon. Each hydrogen will make a single bond with the carbon. And again, these red lines aren't really the bonds. It's just showing you which electrons are going to group up to make the bonds. Then once you kind of know how many bonds each atom's going to want to make and how they're going to be arranged, then you can draw your Lewis structure. Usually for Lewis structures that have carbon involved, carbon is drawn at the center of the Lewis structure. So I have 1 bond to a hydrogen here, 1 bond to a hydrogen here, 1 bond to a hydrogen here, and 1 bond to a hydrogen here. So we have 4 single bonds. Each hydrogen is making 1 bond. That's the number of bonds it wants to make. And the carbon is making 4 bonds. That's the number of bonds that it would want to make. So that would be the Lewis structure for CH4. Okay, let's take a look at one more example. And this is one where you're going to end up actually having a double bond involved. And for this example, we'll take a look at CH2O. So for this molecule, it has a total of 4 atoms in it, 1 carbon, 2 hydrogens, and 1 oxygen. And we're asked to draw a Lewis structure for it. So again, if we take a look, each of the hydrogens, they'll each want to make 1 bond. The oxygen, draw its dot structure out. The oxygen will want to make 2 bonds. And then if we draw the carbon out, draw its dot structure, the carbon will want to make 4 bonds. Now you can just kind of think of these as 4 different puzzle pieces, and you have to arrange them so that every atom is making the correct number of bonds. Now, I'm purposely going to do this one wrong initially. So let's say if we kind of go like this. And say, okay, this is our Lewis structure. Well, a couple of reasons why this is going to be wrong. Yes, this hydrogen is making 1 bond, so that's good. This hydrogen is making 1 bond. The carbon wants to make 4 bonds, but it's not. It's only making 3 bonds. And you have a single electron left over. This is a radical. They do exist in nature, but if you're doing a introduction level chemistry course to draw Lewis structures, your professor's not going to give you a Lewis structure where you got to draw a radical in it. So if your Lewis structure has an individual electron left over like this, you did something wrong. And then if we also take a look at oxygen, oxygen's only making 1 bond, and oxygen wants to make 2 bonds. And oxygen also has a radical as well. So if any of the atoms are not making the normal number of bonds that they would want to make, you did something wrong. And if you have any single electrons left over in your structure, you did something wrong. So what we're going to do is, since carbon and oxygen both want to make 1 more bond, we'll have them bond to each other. So now we have a double bond between the carbon and the oxygen. That represents 4 electrons being shared. The carbon, if we want to see, does it have 8 electrons in its valence shell? Well, each bond counts for 2 electrons. So 2, 4, 6, 8. All right, carbon has 8 electrons in its valence shell. It's satisfied. Hydrogen wants to get 2 electrons in its valence shell. 2. It's satisfied. 2. Does oxygen have 8 valence electrons? 2, 4, and then 5, 6, 7, 8. So all 4 of the atoms are making the correct number of bonds. We've drawn in our non-bonding electrons, and all atoms have filled their octet. All right, that's it for this video. In the next video, we'll take a look at some more advanced Lewis structures, a little bit larger molecules. I hope you learned something. If you did, subscribe and like, and I will see you in the next video.